Let's talk a little bit more about delta H and the relationships between delta H and the reaction as given. Remember, by convention, delta H is given for the reaction as written. So if you have to multiply a reaction by a factor, you also multiply delta H by that factor. So for example, the combustion of carbon with oxygen to give carbon dioxide, we have a delta H value. And then if we need to multiply it by 2, we also multiply our delta H by 2. If we have to reverse our reaction, then we just change the sign of our delta H. That should make sense from our energy diagrams. We can also write for delta H. And so if initially our products and reactants, and delta H is a state function, so this is the distance between them. If we flip it over, the distance stays the same, but now we're going the opposite direction, so we just change the sign. Now, what's the point in talking about all that? The point is Hess's law. So remember, enthalpy is a state function. So if we are looking for the enthalpy of a certain reaction, we can break that reaction down into steps that we know the delta H of and simply add them together in order to get that unknown delta H. So if we can express a reaction as a series of steps, so here we have A plus 2B goes to C, that has a certain delta H. Then we have a reaction C goes to 2D. That's the reaction, that's our second reaction here. C goes, so A plus 2B goes to C. Then we have another reaction, C goes to 2D. If I add those together, my C's cancel out because they're the same on the product side and the reactant side. And I have my overall reaction of A plus 2B goes to 2D. And to find my delta H for this reaction, all I have to do is add my delta H for the first one, my delta H for the second one, and I get my overall delta H by adding them together. So to find this purple one here, I can find out how much energy it took to get up to C, how much is released when we go down to 2D, and then find what happens when I add them all up. Let's work through another example using actual chemicals instead of A, B, C, and D. Given the following information, so we have 2 moles of nitrous oxide plus an oxygen goes to 2 NO2. Then we have a second reaction here, 2 nitrogen plus 5 oxygen plus 2 waters goes to 4 nitric acid. And we have delta H's associated with those. And then nitrogen plus oxygen gives 2 nitrous oxide. Calculate the delta H for the reaction below. So what my goal is to rearrange these 3 reactions to give me this bottom one. Now let's see, I want my NO2 to be on the reactant side. So I am going to start by reversing this first reaction. And I will write in red down here. So now we have 2NO2 goes to 2NO plus O2. And now my delta H, since I flipped it around, is going to be a positive 116 kilojoules. Then I want to make some water, so I'm going to leave this second reaction as it is because I want my water to be a reactant. So 2N2 plus 5O2 plus 2H2O goes to 4HNO3. And for now, I left that as it is, so my delta H is going to stay the same. Then my bottom reaction, I want to cancel out my nitrogen and oxygen because they do not show up in my final reaction. So I am going to reverse that one and do 2NO. Gas goes to N2 plus O2. Now my delta H there, I've changed the sign, so now it's negative 183 kilojoules. Okay, so now I need 3 NO2, and I only have 2, so I am going to multiply this reaction by 3/2 to get my 3. So I'm multiplying all of this by 3/2. So I'm going to indicate what I have now. So 2 times 3/2. Now I have a 3 there. Now I have a 3 there and a 3/2 in front of my O2. And then 116 times 3/2 gets me 174 kilojoules. Now my second reaction looks okay. I have 2 waters there. I want to divide that one by 2. So I'm going to do a 1/2 here. Now I have a 1 there, a 5/2 in front of my oxygen, a 1 in front of my water, and a 2 there in front of my nitric acid. And then my bottom equation here, I want to keep the same because I have 1 nitrogen as a product and I want to get rid of my 1 nitrogen right there. So I'm going to keep that one the same. I need to do a calculation up here. I divided this by 2, so I'm going to get negative 128 kilojoules, and then I'm keeping my bottom equation the same, so I don't have to do any math there. Now, let's work out what my totals are. So, for my top equation, I now have 3 NO2s. That is my goal. So I'm going to write 3 NO2 plus, let's work through the rest of my top equation. I have 3 NOs in the top one. I have 2 at the bottom. So my 2 are going to go away. That one's going to become a 1. So I get an NO in the gas phase. And then my O2s, I have a 3/2 O2 right there. I have a 5/2 O2 right there. And I have 1 oxygen right there. So on this side, 3/2 plus 1 is 5/2. This is 5/2, so I don't have any oxygen left. So I'm done with my top equation. So I can get rid of my oxygens. Then my next equation, I have 1 nitrogen as a reactant. I have 1 nitrogen as a product, so those cancel out. I have my 1 H2O, which I want to bring down to a product. Sorry, to a reactant in my final equation. This should be an L. Then I have my 2 HNO3 aqueous there as my product from right here. And I have taken care of everything in my equations, which means now to find my delta H, all I have to do is add up 174 plus negative 128 plus negative 183 to get an overall delta H value of negative 137 kilojoules. Then here's that whole thing worked out again. You can see the flipped and the multiplied here. And I don't have the answer on that slide, but that's okay. The answer is negative 137. Okay, here's another practice one. This one is simpler than the last one. So why don't you go ahead and pause the video, work through this, and then I will work through the information for you. Given the following information, copper plus chlorine gives copper 2 chloride with a delta H of negative 206. 2 coppers plus chlorine gives 2 copper 1 chlorides. Now we want to know the delta H for the reaction below. Copper plus copper 2 chloride gives 2 copper 1 chlorides. So the key here is to recognize that this we want as a product. So I'm going to reverse my top reaction. So CuCl2 solid goes to copper solid plus Cl2 gas. I reverse that reaction, so my delta H becomes a positive 206 kilojoules. Then my second reaction I want to keep as it is. 2 copper plus Cl2 goes to 2 copper 1 chlorides. So my delta H stays the same. Now I can add things up and check. So my copper 2 chloride stays. This copper cancels out. This becomes a 1. So then I have plus copper solid goes to my chlorine gases cancel out, and I'm left with just the 2 CuCl solid. So then I can add those two together and find my delta H is equal to 170 kilojoules. One more to work through. Use Hess's law, determine delta H for the target reaction. Again, pause, work through it, and I will work it through. So we want our NaCl as a product, or as a reactant. It's a product right now, so I'm going to have to reverse this one. And my top one, I want nitrogen and oxygen as products, and they are currently reactants. So I'm going to have to reverse this top one as well. So let me do that a second. So NO goes to 1/2 N2 plus 1/2 O2. And then my delta H becomes negative 90.3 kilojoules. Reverse my bottom one. NaCl. NO plus 1/2 Cl2. And my delta H also reverses. And then for all of these, all of my coefficients are double what they are in my originals. So I'm going to multiply everything by 2. That will get me, my NOs are going to cancel out. Then I didn't write a 2 there. So I will have 2 NOCl goes to a N2, 2 times 1/2 plus O2 plus Cl2. So my delta H is going to be half, oh, sorry, not half, 2. 2 times negative 90.3 plus 2 times 38.6. So I get a delta H equal to negative 103.4 kilojoules, which is answer C.